So we're finally going to get to exception handling and show a couple examples. And before I said how important exception handling was, particularly for professional programming, because we don't want the program to terminate rudely in a way beyond our control. We want to be able to decide as the programmer exactly whether it's going to continue, give a warning message, or terminate, but terminate politely. So it looks like our software is professional rather than just randomly quitting. So exception handling can be very important, once again. And once again, exception, which is generally a runtime error, is going to happen when Python or the computer is asked to do something that's syntactically correct, but it's either unreasonable or it's just impossible. Some most common examples are a zero division error. You try to divide by zero. You just literally can't do it. File not found error. You said, go read this file. It doesn't exist. We can have index error, which is also a runtime error, an exception, not a syntax error, because it determined that an index you were trying to use for a string or a list is out of range, and it will cause you to terminate rudely as an exception if you don't handle it. So how do we handle exceptions? So we have basically the syntax that says try, colon, have some statements, except with an optional exception name, colon, and have some statements. This is the basic template for exception handling. There's some other optional features I'll discuss on the next slide, but this is the basic template. When we say try colon, we're going to put statements in there that we're attempting to execute. So what this means is simply that first group of statements after the try colon, it just goes ahead and does it unconditionally in effect. And that will just run normally. But if an exception is raised during the try block of statements, if there is an exception raised at that time, then we potentially may be transferred to an exception handling block, which consists of the keyword except, an optional exception name, colon, and then some more statements. So if an exception is raised, then we'll go to the second group of statements and it will just continue executing. And those statements can do whatever you want. They can terminate the program, issue warning messages, or do whatever you want, but then the power is entirely in your hand. There are some variations on this syntax. I haven't shown them all here. We can also have just the word except with no exception name. If you do that, it will simply handle every possible exception. So it's basically a catch-all if you want to take that approach. And you don't have to worry about the program abruptly quitting on you, but you still have to figure out what it did wrong and what kind of warning. What you also might want to do is you can handle several different exceptions, which means that in this syntax you can repeat the word except with a different exception name, which is the name of an exception class actually, or an exception type. You can have as many of those as you want. So you can say try colon statements, you can have except this exception, except that exception, except a third kind of exception. So this is very, very flexible syntax. Optionally, you can also have an else clause, which is different from the else clause in an if statement, and you can have a finally clause. So if in the middle of exception handling, as we'll see in the example coming up, if you have an else clause, so it's else colon, more statements, that actually gets executed if no exception was raised. So if everything went right, it'll actually execute the else clause, which again is optional. But what could that do? Well, that might just say, oh, everything's cool. It might tell the user it was successful. And then the finally clause is executed after everything else. This is part of the exception handling that will close up resources for you. So if you try to open a file, you have open files or open resources in the finally clause, it will close those for you. So now we're going to do a demo that does some of all of this. And this is a common situation, handling files. It's a very common situation for exception handling because often you'll let the user suggest a file name that he or she wants to read. You'll try to open that file, and you have to be prepared that the user might have entered the name of a file doesn't even exist. So what are you going to do? You have to be ready to deal with the exception, to handle the exception. This is a very common situation for exception handling, one of the most common. So we're going to try to open our old friend stuff.txt. If there is any exception, so we use except.colon, that clause says if there's any exception at all, we're just going to catch them all and say there was an error. But at least we're not going to terminate rudely. We're just going to keep going, which is nice. The else clause will say, this is what happens if there was no exception. We say, oh, it was successful. That's generally what you're going to do in those clauses very often. And then finally, we're going to close the file. So let's demonstrate this. And it looks like a bunch of code, a long bunch of code. It's really pretty simple. We're going to try to open stuff.txt as a read text file. So it's read only. Then we want to print it. And so now we have our except blocks. We say except without a name means catch everything. And it might not be a file IO error. It probably is. I'm just going to assume that it is because of what we're doing. And then we'll just print an error message to warn the user. Else, this is what we're going to do if everything is fine. And then finally, the last thing we want to do no matter what is close the file. So if I press enter twice, it will go ahead and run this. If it's successful, it will print the contents. And it will also execute the else clause. At least that's what it should do. And there it goes. So it printed the contents in stuff.txt, which we entered this beautiful Shakespearean verse. And it did that because there was no exception stopping it. Then it executed the else clause, which is an optional clause. It says do this if it's successful. There was no exception. So do this other thing and said operation success. And then finally it closed the file and everything's great. Now, there are other variations on exception handling. There's really no end to the variations on it or the ways you can use it. The way I've often used it is to try to open a file, and then if the file open was unsuccessful, then automatically retry it. So I'm not going to demonstrate this in the environment, but if you look at the logic here, I've put it inside an apparently infinite loop. And what I'm saying is I'm going to get a file name from the user. And by the way, if the user enters an empty string, so just presses enter, it will break because it will say if not fname. So fname, if it's empty, it will say if not fname, oh, that must mean I execute this, and it will break. So I'm just allowing the user a way to get out of this if they're tired of it. So the user just presses return, it's going to break, it's going to get out of it. Otherwise, it's going to go ahead, try and open, try a read. But if it can't open that file successfully, then it will cause the exception handling block to occur, to be executed. And that exception handling block will print, I can't find the file. So it's actually going to test for a file not found error. And if that happens, we'll say file not found, re-enter. And because it's in a loop, it will go back to the top and re-prompt the user automatically. So this is really nice. This is an example of a tight little loop. It's just going to keep going until either the user gets tired of it and presses return, or it actually does find a file, in which case it will go ahead and read it and print the result. So this has been a fairly brief introduction to exception handling, but really covered what your basic options are here. Your basic tools are try and except keywords. Those are your main tools. So basically you're going to say try : and you have some statements you want executed. If an exception is raised during the execution of those try statements, it will be handled by an except block if you have it. You can have any number of those to test for different kinds of exceptions, or you can just have except : which will catch all exceptions. In addition, you can optionally have an else clause. It will be executed if there's no exception, so that means success. And then the finally clause, which is executed after all the others. And these 4 keywords, you will have in your power the means to look for and handle any exception that Python detects.